Hello everyone, I'm Lucas. So welcome to my second video for this year. So this will be the 2025 May time zone A. So time zone A would be like the Asia and also like the Australia time zone. Okay, so this will be my paper 2 walkthrough. So yesterday I make a video about paper 1, right? So today I want to go through paper 2. So but currently I don't really have the paper 3 yet. So therefore, if any of you have paper 3, please send it to me in whatever contact that you got, so say on YouTube comments if possible. So this will be my suggested answer. So I would go through this particular paper using my best ability. So some of the question here might be wrong because like maybe I've done some category mistakes, so please excuse about that. So I want to go through like the general approach of this paper first. So this is a calculator paper, so let's grab a calculator. So I always use like the iPad Numworks paper here. So let's see. So make sure my cat's in radian first. Okay, so good. So let's look at the first question and like look at the whole paper first. So this is a sector question, I think, and then a trigonometry, I think like a rate of change, and then a regression, and then a I think like differentiation, right? Something like this. So, and then this will be a trigonometry, I think. Vector, complex number, and a Euler's method. Okay, so this video I'll go through to section A first. Okay, so according to some of my students, they told me that this paper is actually easier than paper 1. So hopefully this is the case for this one. Okay, so let's see. So number 1, point A and B lies on a circle with circular center of O, radius of 19.5. So they gave you this already. So, and then the paper cut into the shape of a sector BOA. So basically they gave us this already. This is the piece of paper cut in the shape already. A hollow cone with no space is constructed. Basically just change this to this, right? And we know that the slant height here will be 19.5, obviously, because this will be the slant height when you curve it. Okay, so that's the question. Find the area of the sector. So first of all, remember one thing is, please make sure don't use the arc length formula or like the theta r squared divided by 2. The reason is because this is a degree, so therefore we'll try to avoid using this. So we need to use our old school way, pi r squared times theta over 360. Okay, so or you can change like 210 back into radian. That's also okay. It's up to you. So we apply it, that will be pi r would be 19.5 squared times theta, which is 210 over 360. Okay, so pi times 19.5 squared times 210 divided by 360. So it'll be like 696.8445. Okay, so 3SF, that'll be 697, I think. Okay, so that's basically it. The radius of the cone. Okay, so radius of a cone, I think you just go to here and try to find this, right? I want to find this one here. So we want to find the height first, okay? If we got the height, I think we got everything. So let me think. So what can we do in here? Radius of cone, 3 marks. So since we got the area sector, and so therefore I think that the whole thing here, like the whole curved part here, like curved surface area of the cone, so the curved area of cone should equals to 697 as well, because when you curve it, like this is actually like the material that's being used, right? So therefore the cone area, the curved part should be the same. So if we look at the formal booklet, the curved area is pi RL. Okay, so equals 697. So actually don't really need to use the heights in here. Okay, so okay, good. So the next part would be find R in here. So pi is pi, R we don't know, L is like the slant height, 19.5. And then this would be 697, and then solve by doing some algebra in here. So 697 divided by pi. Sorry, like the iPad calculator is a little bit like hard to press sometimes. So it'll be 11.37, so 11.4, okay? So that will be the first part in here. Hopefully it's not really that hard. Okay, so but I think this question is actually harder than the paper 1 first question, okay, because like the thinking stuff might be more challenging. Number 2. Okay, so it's still an SL question, so they gave you a tangent graph and then write that period, right? So remember, for a tangent graph, it's different from sine cosine. If it's sine cosine, the period would be equals to 2 pi over b, right? But for tangent, it's actually different. For tangent, it's pi over b instead. So therefore, this time we're going to use this. Okay, so the period would equals to pi over 2 this time. Okay, so because like b will be 2 in here. Okay, remember b is the number in front of the axis. And then second part, the graph f passes through these 2 points, 5 of a and b. So obviously, I think what we need to do is just sub in these 2 points inside. So we got let's say the first one, so a tan 2 times power 12, which is power 6, plus b, this would equals to 5. This is my first equation. The second one would be a times tangent pi over 3 times 2. So power 3 times 2, that's like 2 pi over 3. And then plus b equals to 7. Okay, so this is my second equation. So all we need to do is just use a simultaneous solver in your calculator. Let's see where I have that here as well. So equation, can I add an equation? I think so. And then let me add another one. Simultaneous. Okay, so simultaneous equation here. So I would just let a to be I'll just let a to be x in here. So I'll just write tangent. Oh, sorry. Okay, here tangent, and then power 6 of pi divided by 6. Okay, so x in here, and a close bracket. So this is, sorry, x in the outside. So it'll be x in here, and this would equals to 5. Okay, and then the top equation would be, okay, so the top equation, so this would be tangent 2 power 3, so 2 pi over 3, and a close bracket, and then y, and then 7. Okay, so let me double check. So tangent, oh sorry, the x should be in the outside. Okay, so tangent pi over 6 plus y equals 5, and then tangent 2 power 3 x plus b 7. Okay, so it should be okay. So we got 2 answers in here. So a would be x. So a would be negative root 3 over 2, and then b would be 11 over 2. Okay, so I think that's basic. Okay, right, as a decimal, that's also okay. So I think that's okay already. Or actually, you can do it by hand. I think that's also okay. So the next question would be a, let's see, a population question. So I think it's a exponential problem here. So a population P has a rate of change given by this model, where T is time after 2022. So we know that we start counting in 2022, and at the same time they gave you the population when it started already, which is this huge number. Find 2026. So we want to find basically when T equals to 4. Okay, because you need 4 years, right? So I think we need to find population first. So P will be the integration of dp dt first. Okay, so we're gonna integrate the thing on the top. Okay, so if we integrate, that'll be negative 104,000. So 104,000, I think, and then e negative 0.0145t dt. Okay. So yeah, and then we need to integrate it. So remember one thing for integration, so number, keep it at the front. And then we integrate e, it's still e, but hope you still remember there's a reverse chain rule problem. Let's say if you got a chain rule happening in the inside, please make sure to differentiate that and put that to the denominator. So we got negative 0.0145, okay? You need to differentiate the inside and put it to the denominator for this part. Let's see. So please make sure to also cancel number. So let's go back to the calculator menu. So I'll just take the numbers and divide by each other. So the negative, it's gone. So okay, just ignore it. So 104,000 divided by 0.0145. Okay, so it's like something million here already. So make sure you copy it correctly. This is the reason why I don't really like paper 2. Okay, so this is C. So we want to find C as well. So at the start of 2022 is this amount, right? So we know that when t is 0, p would be 6.78 times 10 to the power of 6. Okay, so I think we just need to use the calculator and calculate this number out. So 6.78 times 10 to the power of 6. In the right hand side, since this is 0, then e will be gone, so just remaining a number 413.793 plus c, and I will solve c using your calculator. Okay, actually I can just use the answer, but it's fine. So make sure I didn't type it wrong. So c will be negative 392,413.793. Okay, so at the end, what do we need? We want t equals 4, right? So put t equals 4. Then p would be 717,2413.793. E negative 0.0145 times 4. And let's subtract the answer that we got here. Okay, so let's see. So I just take the value here, and then e negative 0.0145 times 4 minus, or actually I just copy this as well at the end. So why is it divided by 1000? I think that's correct. So it'll be like 6,375,834.106. So that's like 1/6 million something. So I think that's basically it. So 6,380,000. Okay, so 6 million something. So it's actually decreasing, right? So we're expecting a negative number, a small number. So this is also a question that I would check at the very end, because like the numbers is actually kind of crazy in here. Okay, so please spend the remaining time to double check for this question. But generally the logic looks something like this. Okay, the next one. It's a regression question, I think. So in a group, the regression line f on A. So f is the foot length, right? A is the arm span. So we're going to look at like the body structure in this question. So they gave us 2 regression lines already. This one and this one. This one and this one. Okay. So actually this part here, I think they are pretty nice. Normally you should remember that all of the regression line will always pass through the mean of the x and y value. So this is something that you need to remember generally. But they gave you in here, which is pretty lenient. So use a appropriate regression line, find estimate of arm span when foot length is 19.8. So we want to find a equals to what, right? Given that f is 19.8. So whenever you want to find a, we're going to use the regression line of a on f. Okay, so meaning that a will be a y and that f will be an x in here. Okay, so we will go to the equation that looks like this, which is this one. Okay, so this is y and this is x. So will be a equals to 2.89 times f. F would be 19.8. Okay, so and then plus 99.3. Okay, before you type in, make sure the units are the same. So this is cm and this is cm, so it should be okay. Just in case that they will trick you on the units. So 2.89 times 19 and then plus 99.3. So 156.522. Okay, so A would be 157, something like this. Okay, so B. For a group of adults, find mean span of the foot length, right? So I think for this question, all we need to do is simultaneous equation, because we know that both of them pass through mean point. So we want to find their intersection, which will be their mean. Okay, so A minus 32.6, and I'm going to regress. I want to simultaneous this with A equals to 2.89, 19.8 plus 99.3. Okay, so the numbers are so ugly. Sorry, this is F. Okay, sorry, I didn't recognize that I'm copying the wrong stuff. Okay, so we want to simultaneous these 2 equations. So all you do is just put in the second equation to the top. So we got F equals to 0.353, 2.89F plus 99.3 minus 32.6. So what I'll do, I'll use the calculator to do it, because I'm lazy. So F just treat it as X, and then it'll be 0.353 times 32.89x plus 99.3, and then minus 32.6. Okay, so let's see. Okay, so 0. What is it be 0? 32.6. What x is 0, y is 0, right? So let's see. Maybe here. But this is a negative. So she shouldn't be negative, right? So let's see that copy wrong the question. So 32.6. 32.6. Oh, is this really a negative number? Wait, so let me see. So 0.353 times 2.89. Ooh, it's really a negative number. 2.89f, 99.3, 335. Oh, sorry, I think I copied wrong the question. It should be 335. Okay, because I found out like the number is a negative number, which is not correct. Okay, so I'll just change the value here. So that's why you know you're right or wrong sometimes. So if you copy wrong number, we use a weird answer. So 0, 8, there's another one here. So the intersection will be 20 point something. So we know that f, which is the x, will be 20.89482. Okay, so around like 20.9, I would say. So arm length, you put it back in the second equation here. So 2.89 times f, which is like 20. Excuse me. And then we're gonna add 99.3. So 159. Okay, something like this. Okay. So 3SF will be around like 160. So B is done. C. So I think it's a normal distribution question now, okay? So the height of the adult could be modeled by normal with mean of 163 and an SD of SD, which we don't know. It's found that 88% of the adults will have heights between 153 and 173. Find SD. So actually this is obviously a Z-score. Whenever like the mean or SD is unknown, we'll use the Z-score in here. So 88% lies between 153 and 173. So basically just as x. Okay, so between, actually they use h, so I just follow it, use h. Okay, so 153 and 173. So 153, 173, 88%, right? So 0.88. Okay, and find SD. So we'll use the z-score formula. So 153 minus the mean is 163 over SD. And then this is the same thing. So apply the z-score formula in your formula booklet. It's actually I'm going to go over that later. So 163 over SD. Okay, this first. Okay. So we're gonna do something like this. And then the middle becomes a or is there an easier way? 3 marks, right? Maybe I'll just draw it out because maybe kind of hard to understand. So 153 and 173. And at the same time we have the mean as well. The mean is 163. And they told you that the whole thing here, it's 88%. This is 10. This is 10. Oh right, this is like they're the same, right? So therefore, if the whole thing is 88%, and since 163 is perfectly in the middle, which does 10 is 10, right? Then this part here should be 44%, right? And this part here would be like how many? Like 50 minus 44. I think that's like 6%, right? So I think we have this thing here. I think this is like easier. So let's try to restart. Okay, because sometimes it's easier to do one tail. So one tail means that we only have like one inequality and stuff too. So probability x less than less than 153, it'll be 6%. Okay, so we'll use the z-score again. So h minus 163 SD. SD, and this is the same thing, 153 minus 163 over SD, 0.06. The left hand side becomes a z-score. The right hand side is like negative 10 over SD. Okay, and then we use our GEC. So GEC just goes to your normal distribution. So really depending where you're using TI Inspire or the Casio. Okay, so we'll use normal C. We'll use like the inverse normal for this one. Okay, so mean, remember it's 0 and 1 because it's Z score. Okay, and then use your inverse normal, have you find the boundary. So less than and then 0.06. So negative 10 over SD would equals to negative 1.55. Okay, something like this, 1.554774. Okay, so the SD, do some algebra in here, will be 10 divided by the value, 1.554774. Okay, so make sure that didn't type wrong. So 6.43. Okay, so this is also a question that you need to check at the end as well. So I think this is an SL question. Okay, hopefully that's okay. Okay, so one more SL question, I think. So consider function h, which is given here, and then this is the function itself they gave it here, and then there's a tangent that passes through this point. Okay, find the gradient of tk in terms of k. So obviously, whenever you find gradient of tangent, you need to differentiate it every time. Okay, so we differentiate top, right? Sorry, it should be h dash. Okay, so first of all, differentiate the cosine, right? So negative sine, and then copy the inside. So this is a chain rule 100%. So you need chain rule inside, which is pi over 50, because you need to differentiate it inside, right? And then 15 is gone. Okay, so, and at the same time, we want to find when it's k, right? So we just put k inside. Pi k over 50, pi over 50. Okay, so since it's an exam, please make sure to also simplify the fraction if possible. 3 out of 10, so negative 3 out of 10 pi sine pi k over 50. Okay, so I think that's basically it. Okay, so in terms of k, so 3 marks. Part B, consider the case where the angle of tk and the x-axis is pi over 8. So meaning that this is pi over 8, okay, which is like around like 22 degrees. Okay, so the next part is we want to find the values k that allows this gradient, right? So one thing to remind you is, first of all, remember the logic of gradient when you learn in GCSE or MYP. It's all about rise over run. Okay, so whenever the gradient, it's always about it. So the slope, it's always about rise over run. Okay, so when you're using rise over run again, so remember when you learn about SOHCAHTOA, tangent, it's opposite divided by adjacent, right? So therefore, if you tangent this one, it'll be rise over run already. So therefore, the slope by itself, it will equals to tangent of pi over 8. But the problem here, you need to be careful, is that the slope is actually dropping down. It's actually going down, right? So therefore, it should be negative. Okay, so just be careful with this part. So the slope will be tangent pi over 8, which is like how many? Like tangent, negative, sorry. Oh my god, okay, so negative tangent pi over 8. Make sure it's radian mode. Enter. So negative 0.414. Okay, so almost done already. So all we need to do is just set h dash k equals to negative 0.414. Okay, so there should be 2 answers at the end because like possible values, right? So okay, so we have a domain as well. So between 0 and 50, as long as answer between 0 and 50 should be fine. Okay, so just type the left. So negative 3 over 10, and then pi sine pi x divided by 50. And then I think that's our first equation. The second one is negative 0.414. Okay, so we'll set the axis. Okay, so between 0 and 50, right? So we're looking for the first one. So k, it will be 7.24. And the next answer, it will be 42.8. Okay, so there should be like more answers. So if you look at the next one, it's like 107, which is out of the domain. So therefore, only these 2 as our final answer. Okay, so done already this one. So now all of the SL questions done. Let's move on to the AAHL one. So now consider the function of 4 cotangent x plus x. Write fx in terms of sine cosine. Okay, so this is pretty easy. So remember, cotangent is the flip of tangent, so therefore it's cosine x over sine x. Okay, so I think that's basically it. Hence, otherwise, sketch the graph. Okay, so pretty easy. So it's cosine x and then divided by sine x, and then plus sine x. Okay, so and then between 0 and pi, right? So I need to change it 0 and pi. Sorry, 0. Confirm. Okay, so the x is like kind of weird, so I just set this to be -10 to 10 and see where I can see a graph. Okay, so it looks something like this. So showing the value of x-intercept. So let's plot the x-intercept first. So 2 point something. So 2.24, I would say. Okay, so this is the part. This will be pi, I think. This will be 0. So it's like more slanted to the side. Okay, so maybe let me draw it better. So I think there's some asymptotes in here. Okay, so yeah, that's basically it. So showing the value of x-intercept. So I think that's basically 3 marks. Pretty easy. Part B. Find the value of f inverse 2. So f inverse 2. All we need to do is just go to your graph. So normally in the inside it's x, right? Normally, but now you inverse it, so now it becomes y. So what we need to do is we want to find what's the x value when y equals to 2. So we just go outside here, put 2 inside, and look for the intersection. So let's hope it's a nice number. Okay, not really nice. So 0.612. Okay, so part C. Part C. Given that secant alpha is 1.5, find the value of f alpha. Okay, so secant alpha, right? So secant alpha 1 over cosine. It's 1.5, right? So okay, so let me see. Okay, well, okay, so let me delete the whole thing first. So 1 over cosine, right? So 1 over cosine x, and then 1.5. The first answer. So the answer for alpha is 0 and pi, so therefore it's only this one here. So alpha would be 0.841. So and then we want to find out f alpha, so f of 0.841. Okay, so I think you just need to plug into this formula here. Okay, so pretty easy. So just go to the normal calculator screen. So sine 0.841 divided by sine 0.841, and then plus sine 0.841. So 1.63986. So 3SF 1.64, I think. Okay. This question I think is kind of stupid, to be very honest. Okay, pretty easy for this one. Okay, 7 marks. Okay, vector. So this might be a harder one. So it's a long question as well, I think. But it's only 5 marks, to be very honest. Okay, so I think if we don't know how to do it, I think it's fine. So at 9 a.m. in the morning, the helicopter is located at this one. So this is an important equation. So let's highlight it. Relative to origin, so horizontal ground. So x is east, y is north, and z is vertical upward. So let's say if you're looking into the paper, this is x. Sorry, yeah. This is x. This is y direction, and if you go up, like go upwards, right? So let's say move out of the paper. So it's like physics, right? So move up, then it will be z. Okay, so flying at a constant height as well. So the helicopter's position is actually this one. But actually, if you look at this carefully, this is the starting point and this is the direction, right? It's 0 in here. 0 in here meaning that it's not going up or going down. It's just moving horizontally. Basically, like diagonally or horizontally. So this is just move horizontally without any vertical movements. Okay. Find the speed of helicopter. Bro, this is like kind of cheeky. Why did they put a 4 in here? So normally we will not have any parameters, right? So I would recommend you the direction vector updated first. The direction is like 40 over -100, 0. Okay, be careful about this one. Times the 4 inside first. Okay, so when you understand how do we read this, basically you started here, right? So imagine this is like 40, right? each time when you increase t by 1, it will walk this amount, right? So let's say if t is 2, then it will be 2 times of this. So therefore, what's the speed? The speed will be the length of this particular magnitude. So the magnitude of the direction, it's equals to the speed of the helicopter. Okay, so therefore it will be 4t squared plus 100 squared, and 0 squared, you can just ignore it. So root 4t squared plus 100 squared, and then you root it. So it's like 107.7. Okay, so remember one thing, since like every single step, right? So let's say when t is 1, it'll be this one. When t is 2, it'll be 2 times of this. When t is 3, it'll be 3 times of this. Meaning that each second you're moving this amount of like direction. So therefore, if you can find a distance in here, that will be the speed. Because like speed is like how many that you move per second, right? So it's all about distance per second. So you just need to find a distance in here first. Okay, and that will be the speed. So that's basically part A. Part B. So let's see. Part B just 3 marks. So to be very honest, if you don't know how to do, I think it's okay. You can just skip it. So number 10, at 10 a.m. it started to descend. So basically 1 hour after. During the descent, the helicopter vertical height decreases at a constant rate of 16 kilometers per hour, and the horizontal velocity remains unchanged. Find the angle of descent, beta. Okay, so meaning a helicopter, right? So imagine this is a helicopter. Okay, sorry, my ugly drawing. Okay, whatever. So like this. So it's like going downwards, right? So I just draw a straight line. It's like descending. So, and then we want to find this angle. Okay, it's not going towards the ground. It's just going downwards. Okay, and this is called beta. So it's dropping at a constant rate of 16 kilometers per hour. So if I try to draw it out in here, actually for this type of question, you can just imagine that it's 16 km. We just think of this like per 1 second. Okay, like the whole diagram here is like per 1 second. Okay, and then the question told you that the horizontal velocity remains unchanged, meaning that this part is still 107.7. Okay, so meaning that in order to achieve this, the helicopter actually needs to go diagonally like faster in order to maintain this particular horizontal velocity. Okay, so we want to find beta. So I think we just need tangent in here. So tangent beta equals to 16 over 107.7. Okay, so beta. So in degrees. Okay, so change your calc to degree first. And then find this. Okay, so shift tangent of 116.107.7. Okay, 8.45. Okay, so I think that's basically it. So let me see. Hopefully I got this correct. I have no idea. Hopefully this is correct. But it's like 107.7. Okay, so 8.45 degrees. Okay, hopefully this question is actually like really unknown, but this is my best approach. So because like its horizontal remain unchanged, right? So meaning that the helicopter is like moving at a speed and then goes downward at a more rapid speed in order to maintain this particular horizontal motion. Okay, so that's my best ability for this one. So remember, immediately change back to radian after you finish it. Okay, so next one. Wow, complex number. Show that HT is this thing here. Okay, so first of all, I'll just write out what's HT first. So HT equals to sine 2t plus 1 plus sine 2t plus 3. And then show that this is the imaginary part of this thing. Oh, actually, this is like an AAHL problem. Complex number. To be very honest, like this is like a exclusive AAHL complex number problem. It's like normally in AAHL they will learn about how sine and cosine add together and then use your calculator to do it, right? Actually, you don't really need to use like a non-calculator. You can use your calculator to help you in here. But for part A, you can just start at the question. So the IM. So just what you can do is just consider the multiplication, right, of E2I and then EI plus E3I. I think this question is a bit borderline because a complex number would not ask it this way. This is like really an AAHL problem. Okay, so it's like kind of questionable in IB sense. I would ask a different problem, but I will not ask this type because like normally like a student would not do this type of question because it's fully calculator. So we expand it. It will be e2ti plus I plus e2ti plus 3i. So you factorize the I, 2t plus 1, and this will be 2t plus 3. Okay, so if I want to find the imaginary part of this thing, then remember like Euler's form, right? This is like cosine plus I sine, cosine plus I sine. I want to imaginary, meaning that I want a sine only. Okay, so which is HT. So these questions are kind of like hard for A because like it's kind of unfamiliar. It's not really hard, but kind of unfamiliar. Okay, so that's basically it. So next one, part B, write this as a form as REI theta. It's actually kind of surprising that for this time zone A, like the Asia and the Australian time zone, both paper 1 and 2 ask like Euler's form instead of like the normal cis form. Okay, which is kind of sad for a lot of students here because like a lot of my students ask me a question about like the cis form, right? But actually rarely do anything about Euler's form because like this is more in the AAHL syllabus. Okay, so what you can do is in your calculator, make sure that you can turn on your complex mode first. So I will turn on the exponential mode. And same thing for Casio or for Tan Inspire, you can also turn on the complex mode. And now I think you just type in the whole thing inside. EI plus 3. E3i. So for a complex number for addition and subtraction, we'll always use the calculator to do it. So it looks something like this. I still remember this question like asked by a lot of my students, and none of them know how to do it, right? So actually the reality is just use your calculator complex mode and then just type in the whole thing. So this is kind of funny for this one. Okay, so I think that's basically it. Okay, so EI2, right? So as long as your theta here, like 2, it's between negative pi and pi, it should be okay. So 2, it's of course between the range, so it's fine here. Part C, hence I will show this. So HT, right? So HT would equals to the imaginary of E2ti times this part. So this part we got that already. It's like 1.08 E2i, right? We just sub the top part inside. So if we expand it, it becomes imaginary of 1.08 E 2ti plus 2i. So this will becomes just like Im of 1.08 E factorize the I, 2t plus 2. Okay, so the imaginary part will be 1.08 sine 2t plus 2 because like cis, right? So the imaginary part is just the sine part. Okay, so 2t plus q it's between 0 and 2 pi. Yeah, I think that's basically it, right? Okay, so yeah, I think so. So is there a way to check answer? I think so. So what you can do is just go to your graph. ft plus gt, right? I just sub in this inside. So sine 2x plus 1 and also plus sine 2x plus 3. And then first is like the 1.08 sine 2, and see where the graph does overlap. If it's overlap, meaning they're the same thing. Okay, they overlap, right? Basically overlap. There will be a little bit of error because like around like the number in here a bit. So it'll be overlapping. So therefore, these two are practically the same. So therefore, this must be correct. Okay, so I think that's basically it. But this question really for AAHL is a bit like unfair. Okay, differential equation and the Euler's method. Okay, so let me see where my calc can do like Euler's method stuff. It's a sequence. Add a sequence. But I don't really trust this, to be honest. So un Actually, I can try this. And then can I add another one? Hey, I can add another one, right? Okay, let's try. Okay, let's try to use a sequence here. So for this one, right, step length of 0.5. So we know that xn plus 1 equals to xn plus the step length, which is 0.25. And then for your yn plus 1 would be yn plus the step length, and then times the differential. So 2xn over xn squared plus yn. So I think that's the thing that we need. And we know that x1, where basically the start, is 1, and y1 it's 0. And then we want to do up until x equals to 2. Okay, so we'll just use the formula here. So let me try to use this calculator. So just imagine u is x. So u and u1 plus 0.25. Sorry, 0.25. And then u1 basically start, which is 1 for x. And then v will be like the y value. So vn. Okay, so let me change this one. Vn plus 1 will be the old y value plus 0.25, and then times bracket 2 times un, which is the x, and then the bottom would be un squared plus yn. So yn would be the v, right? So vn. Okay, I think that's basically it. And then for v1, it's 0. Okay, so let me see where I type correct. Step length 0.25, start at 1, and then 0.25 to un, and then un plus vn. Okay, so I think, okay, display value. So I want x equals to 2. Like this one, right? So 2, and it'll be 1.26 something. I'm not sure whether the answer is correct, because like this is the first time that I use this calculator to do Euler's method. Okay, so yeah, okay, 1.26. Any SF? No SF, right? So 3SF, 1.26. Okay. Determine whether A is a over or underestimate, and they gave you a graph in here as well. So 0, 1, right? So we basically want to predict this and predict somewhere to here is 2. Okay, so meaning that at this point the slope is 2. So at this point the slope is also like 1.26 as what we got just now. Under or upper estimate. This will always be an overestimate, because like overestimates. The reason is because the curve at this point is actually concave downward. Okay, so concave downward, because concave down at x equals to 2. Okay, so that's basically it. So anything about like Euler's method, like overestimate or underestimate, if it's overestimate, means that it's concave down. If it's underestimate, it'll be concave up instead. Okay, so this is something that you need to remember. Justify the Euler's method why this does not lead to a negative value when x is 2. Okay, so meaning that why the value that we got in here, it will not be this part, right? So why is it like giving you this part and not this part? To be honest, like in this particular region, oh right, this like why is this the reason, right? Like what I would write is something pretty stupid, because I don't really know like the answer for this one. So what we do, I will sub in 1, 0 into here first and look for the slope. So we'll put 1, 0 into the dy dx first and look for the value. So which will be 2 over 1 plus 0, which is 2. So we know that at this point it's going up at a slope of 2, right? So since, what I'll do, right, since dy dx equals to 2 at 1, 0, this implies that the graph of fx is increasing, right? Increasing and greater than 0. Okay, because like it's increasing, right? So it must be greater than 0. So therefore it will be positive value at x equals to 2. Okay, so meaning that if we start at this point, right, to be honest, we have two routes, either this or this. What we need to do is just sub in the Euler's method for this point inside and see where it's like going up or going down. If it's positive, meaning that we're going to the side. If it's negative, meaning that we're going to the other side instead. Okay, so since it's just a 3 mark, right, this and this will be 3 mark. I think this will have 2 mark, this is just 1 mark only. So therefore, if you cannot get this, I think it's fine. Okay, but this is my best answer that I can give. I think there's also another way, is maybe we can find this part first and then show that this point it's not this part, so therefore it's only one side that we can go through. This is my another way of answering it, but I think this might take too long, so therefore I'll choose to not do that. Okay, so that's basically section A. So I think I finished section A already, so hopefully up until this point, I think this paper, like this one, right, I think it's harder than paper 1 in my opinion, because like normally tangent graph is very rare that they will ask, and then this is actually easy, but like the numbers need to be careful a little bit. And then this is, I think, just annoying but still pretty easy. This is a bit hard actually, so you need to remember that what's the logic behind slope and the angle of incident with the x-axis. This is easy, obviously. The vector, really I'm not sure about part B. Hopefully my part B is correct, like 8 point something. Okay, so this is like the general logic of direction and speed in vectors. Okay, hopefully my part B is correct. This is hard. This is really hard, to be honest. Okay, because some of the student doesn't know that you can use calculator to help you do this. If you cannot do B, then you cannot do C, unfortunately. Okay, this one just weird, not hard at all. But I would say that this paper is like more weird compared to difficult. Okay, so it's weird. Okay, so later I'll go through section B as well. So hopefully section B it's a easier question. Okay, so I saw some crazy stuff later. So thank you very much. I'll see you in the next video. Thank you.